So land acknowledgement. This is where I am based out of, which is Peterborough, Ontario. So we're owned and operated on the treaty and I'm trying to find it here, and treaty and traditional territory of the Michi-Seg Anishinaabe. We want to acknowledge their ancestors and future generations. So for me, I spend a lot of time in the social impact world. I spend a lot of time working with Indigenous peoples. And they've always said, you know, put some meaning into your land acknowledgement. So that, to me, means that I help you to understand what your social impact is going to be on Indigenous people. So when we are looking at automation, when we're looking at digitalization, all of these things are very important, but it has an impact. And that's something that needs to be recognized and thought about as we're starting to roll out these technologies. So that's me. I'm in Australia. I'm sitting on Paddy Hannan's lap. Those of you that are familiar with Australian mining know of Paddy Hannan. That was taken in Kalgoorlie at Diggers and Dealers back in 2018. And I'm jumping off of the dump truck from the super pit. I've been in mining for about 15 years. I've always worked in the mining services sector. So I spent 10 years with SGS. Hi to my former colleagues. Nice to see you. And I worked at the global and national level. So I worked in environmental sales at the national level, and then I moved on to global sales and market development for them. I focus on strategy development. So what that means is I help you grow in a socially conscious way by building strategies that communicate your value proposition. So to the business case, that's an internal value proposition that you need to build. Externally, I work with service providers to do go-to-market strategy. So how do you scale? What is your market? If you want to enter a new sector, how do you do that? Who are our targets? What are we looking at? What makes you different is what I work in. And it's really an interesting job because you come out with a nice, fun pitch deck that you can give everybody, but there's a lot of background information that goes with that. Furthermore, I also work on employee value propositions. So as a producer or proponent in my world, why are you attracting young talent? We talked today about competing against Microsoft. That's important, right? If we're going to compete against Microsoft for talent, we better have a really strong value proposition. And why do employees want to come work for us? Because if the choice is there, they might choose Microsoft because tech has a nice clean image, and unfortunately, mining does not. I'm not saying I'm anti-mining, by the way, just putting that out there. I actually quite believe in it. I give back quite a bit to the industry. I am officially now on the Human Resources Development Committee of PDAC, which was a very exciting thing as a non-technical, non-HR person to join. I participate in their CEMI, which is Student Industry Mining Education Workshop. And I also do a lot of talks like this to new professionals, young talent, boardrooms on how to attract young talent, etc. So a note on today's discussion. Social responsibility goes beyond what you do in your community. It's also the contract that you have with your employees, with your talent. So when you are building when you're thinking about what does social responsibility mean to me, yes, it looks like what you do in your communities, absolutely. But talent today wants to work for an organization that is ethical, that understands what their commitment is to the environment, that has good governance. And so all of that needs to combine. In my world, owners and operators are proponents, and service providers are the ones that provide those services to the mines, just so that we are aware of the language that I'm using, nobody's getting confused. So let's talk about some industry trends. We're not producing enough. Doug put that out. We all know this. We have an issue with that. We have higher demand and not enough supply. It's unfortunately at this point getting worse and not better. That's why we're here today. So the deficit risks the move to net zero, and that's a key focus for millennial and Gen Zs. So again, going back to that social performance, how are you tying that together? How are you providing that value proposition that you get to work on really fun projects? You're solving challenging, complex problems. You are working in communities that are accepting of your project, et cetera, et cetera. We also have a significant brain drain. Women, which we can't attract to the industry fast enough, are unfortunately leaving the industry as well. So with that goes a lot of talent and a lot of just that availability of people that we can use and that we can tap into. Unfortunately, I found out that my local college, which does a geoscience technician program that gives direct entry to university, they've shut their program down. This program was industry recognized, and that is just one example of how we're losing talent out of the industry. And young talent isn't choosing mining. We have a reputation issue. We need to work on that. I don't think that's news to anybody. So, saying that we need a more cohesive value proposition as a mining sector is really challenging to say because it's, a global sector. How do you do that? Many organizations do not have an employee value proposition. You need to have one in order to attract your talent. It's now a must-have. And the onus is placed on the proponents. So our change is a cross-sector change. It's not just a mining problem as far as proponents are concerned. It's all of us in this room. It's my problem, it's your problem, it's everybody's problem. And so we need to start working a little bit better together to start to solve that gap. So first, let's link external work to internal value. Sorry, I move around a lot, so I don't mean to be stepping away from the mic. I'm trying to keep still. So your external clients and partners, they're your rights holders, your governments, investors, and buyers. Organizations are expected to do more. Value is no longer corresponds with share price alone, but we are now working towards a common good. We are working towards making this a better planet. Your internal clients are your talent. Millennials and Gen Zs are idealists. They want to know that they work for reputable companies that conduct business in a reputable way. They believe that purposeful work improves the social paradigm and the environment. And by improving social performance, you can attract an invested talent, and that talent will be invested in your success. So that looks like a return on investment of less cost to recruitment, less cost to retention. They want to help you because you're helping the greater good. So this is how we expect social responsibility to happen. You have government, they put out some laws, some regulations. Associations should be there as well. They interact with indigenous peoples and the miners, and then the service providers are over here somewhere, I'm sure my SGS colleagues are happy that I took out the lab case study. But service providers are over here, that some of them are doing a great job, some of them are not doing such a great job, but there isn't a cohesive, what's the word I'm looking for? A collective conscious to get involved with that triangle. So they sit kind of on the outside. But we should make social responsibility happen by working together across the sector. Again, it goes to my point that it's everybody's responsibility. So, one of those questions is, as a service provider and a proponent, when you are adopting this technology, how many people have thought about how this will affect their impact benefit agreement? You don't have to put your hand up. I'm not looking to single you out. It's just something that you have to think about. Because your impact benefit agreements are impacted by that, right? And it's not to say that you can't disrupt your mining with your innovation. You absolutely can. But you need to find a way to do that so that you are not losing those jobs, or you're mitigating a loss to those jobs that you've agreed to, that they understand what's going on, how if we are decreasing carbon in our process, which we need to do, which they have an interest in, how are you communicating that to them? Are you doing it with engineering speak? I work in the white space of engineering and social communications, right? So I'm not an engineer, I'm not a geologist, I can speak that language, and I can translate that to our communities. My role as go-to-market strategist, especially for the proponents that may think, you know, my share price is my market, my role is to say, yeah, but you're also dependent on the communities in which you work. So it's important to be able to translate that information. And there's, you know, social impact, that's what you do. But it's important for social impact and social performance in those functional groups to be embedded within your innovation space and your HR space. So that kind of goes to social innovation design. Has anybody ever heard of this nice little buzzword? Because every university out there is making money off of it. So social innovation design is looking at these really complex problems and just putting a social lens on it. So again, I was really afraid when I did this presentation that everybody would look at me and say, oh my gosh, she's anti-innovation. I'm not, because we know that we need, in order to get to net zero, in order to keep all of this, we need to transition from big oil and hydrocarbons into metals and mining. But it can't be at the risk of what you're doing socially. So social innovation design means looking at a problem holistically and creating a solution that meets a need while improving social outcomes. So we can't solve an isolated problem like the talent crisis and expect it all to be well. Isolated problem solving results in potentially uncovering more problems. So the result is effective, efficient, and sustainable operations that incorporates a triple bottom line, which is people, planet, and prosperity. You can put the prosperity and put in profits, that's fine. But that's what that means, is that you have to look at all of those pieces, not just your share price. So, social well-being, environmental health, the just economy, it's essentially the same thing. So how do we push innovation outside of technology to include our social responsibilities? How do we start to discuss what innovation looks like, not just in the technological and digital sphere, but also in the social sphere? Because it's essentially the same thing. It's two sides of one coin. When I was at CIM this past year, I was actually speaking to the government, and I spoke with MICA as well. And I asked them that question, is how are we, without social responsibility, innovation can only go so far. And it stops, because to Doug's point, your social license to operate is the one thing that's going to slow down projects. So you can't embed technology into a project and think that everything is going to take away your social problem, right? So let's look at Rio Tinto. Rio Tinto has an automated mine, it's fully automated in the Pilbara. I can never remember the name of it, I'm sure you all know what it is. But a fully automated iron ore mine with 600 people that work at it once it's completed. 600 people, like that's nothing, right? It decreases on your subs, it decreases on your, the people that you need to have on site. So it's great because it's going to be a more environmentally friendly mine, have less carbon impact. But how does that affect your social license to operate? Just a question, something to think about. So let's look at the impacts of automation. Problem, we have a talent deficit, so we've decided that, right? We know this. Baseline scenario, according to the Mining Industry Human Resources Council, states that we have a net employment change, that should be as negative, beside that 9,600 people in Canada by 2033. And we have a massive amount of jobs to fill at approximately 158,000 in order for us to meet the demand as it currently stands. Solution is we're going to automate. Absolutely, 100% yes. We can go deeper, we can operate more safely, we can do these amazing projects with these really cool robots, and it's going to solve our talent deficit. It will, absolutely, but at what cost? So this is the social impact of automation. In Australia, machinery operators and drivers account for 55% of our Indigenous employment. It's pretty significant, right? Automation will remove those rules. We'll hire gamers. Perfect. Gamers tend to be white male at a pretty high number, right? So now all of that diversity, equity, inclusion that we've been speaking about is a bit more of a challenge. So in solving that one problem with an isolated solution, we have opened up another problem, right? So that social innovation comes in where you start to think, oh, how am I going to do this? What am I doing? What is my impact? You know, whatever is my social license to operate. So this is not by means a case study that I've worked on. This is just my brain thinking in the few minutes that I had. But so how can we automate but increase our social performance? It does require the full sector approach that I was talking about. It requires all of us to have that input. It requires us to attend conferences where maybe we invite people that don't necessarily agree with what we're doing. And that's okay, right? I know we are in this world where, unfortunately, it can be pretty dichotomous at times. But diverse thinking provides diverse solutions. So we need to be open to hearing what they have to say. And that's okay. So we have to work with the proponents and the right holders to mitigate the impact and increase the opportunity and increase our productivity, what we're able to mine, how we're able to get there, and do it at lower costs. So what if we set up a gaming education program? What if during the project planning process we say, 5 years, we want to open, we have this project plan, and in 5 years we want to be fully operational, but we're going to be autonomous. So right now, how about we grab that grade 9 kid gaming away someplace and teach her how to drive a vehicle? Participants could include your community and local education facilities. You tap into the high schools. We talk a lot about recruiting early. Recruiting early looks like grade 7, grade 8. Teach them now. I take my 13-year-old daughter to PDAC. Hand to God, she wants to be a driller. I'm like, okay, let's do it. Let's teach you how to drill. I took her through the entire process. We went and looked at the drillers. We went and looked at the core logging machines. We talked to the metallurgists. I learned way more about drilling than I ever thought I would. But she now thinks that mining is a really cool career. So let's start attracting them then. Also, let's start to look at those college programs that unfortunately was discontinued, which honestly gutted my heart and soul, and say, as an industry, wait a second, don't make that decision. That's a terrible decision. We're already dealing with the talent crisis. Please don't. I will sponsor you. There's definitely business models out there. Cambrian College has Glencore on its buildings, right? So how can we look outside the traditional mining towns that we live and work in and say, where else can we start to provide some more support? Look at Indigenous-owned gaming firms. They are there, they exist. How cool would it be if a service provider and a major went to an Indigenous-owned gaming firm and said, we want you to create a SimCity of mining? Because the SimCity of mining modules exist too. So how can we partner together to get that grade 7, grade 8, grade 9 girl into gaming? And then the proponent, right? So they need a deposit to learn on. Could we give them a retired asset and model that? Valet at Copper Cliff, they've done some really great things with Indigenous and community employment. So what they've done is they've decreased the education that's required to drive the trucks, because you don't need a college degree to drive a truck, and you do not need a license to drive a truck on private property. And then they put them on a training deposit, so they get real-world education. Let's do that in the gaming environment. My gosh, my son would be over the moon. He spends so much time on YouTube watching gaming videos. I do not get it. I'm like a Zennial. I don't understand, but I'm sure he would be driving a hauler in like no time, or, you know, whatever type of automated machinery you want to put underground. And that's how you include diversity, equity, inclusion, Indigenous engagement, and solve a problem. Just like that, half an hour. There you go, my solution to you. Take it and go. But I'm a big fan on getting young kids into mining. We work in silos because we are taught in silos. It's not their fault. And so how can we look more across the boundaries of education to build better teams? Just like that, I'm done. That was nice and painless, right? Questions, please? Somebody ask me one. Yes, sir.
So I think you identified talent as a challenge.
Sure.
Is it also a demographics? I mean, a lot of people retire.
Sure.
Probably not enough people coming up to replace them. So you can talk a little about that.
Yeah, sure. So Prospector just put out, if anybody follows Prospector, it's an online media outlet on LinkedIn. They just put out a demographic graph last night that showed that senior management in mining, 44% of that are in the ages between 60 and 79. That's a lot, right? So yes, we do have a talent issue as far as retirements and natural attrition, absolutely. And that is going to be a massive gut to fill. So part of that means looking outside of the industry, and who can we attract? Non-engineer, non-geologist, I'm a communicator. The number of jobs I have been turned down for because I am not an engineer is astounding. But I don't need to be an engineer to build strategic growth plans. I need to understand the value chain, I need to understand the holes, who the target market is, and what your value proposition is. If you can tell me to me in a, I don't know, call it grade, well, let's see, I'm showing my age. I was going to say grade 13. They don't even have that anymore, grade 12 level. I can probably figure out where you need to go to grow and then show the return on investment. So we need to be more willing to accept different backgrounds, as well as, so between that and developing the automation, we can start to level the playing fields. And we also need to, this is a whole nother discussion that I can talk to for hours about, we also need to make sure our people feel like they belong. That's really important. This is a very diverse crowd. I was so excited when I was like taking pictures. I hope that you feel like you belong in this sector. I want you to feel like you belong in this sector. That's really important. Doug's gonna tell me to go. So just on this. Okay, final thoughts. Innovation and social responsibility require a cross-sector approach and pairing of social performance with technology advances. When we co-create, we develop a better, more resilient sector. Thanks, everyone.
Thank you, Peggy. I'm just here to make sure that we can all return quickly to our comfort zone, which is the one with all the male engineers in the room and the other innovators. One thing that I think is important to note also, that in Canadian society, the mining sector is more marginalized than is the military. They have an easier time of attracting employees than we do. And one of the reasons for that is because they actually fund programs for people to go to university, do their degree, and the deal is you have to work for us for 3 years at least, and then you can go on your way. And since many of the things we want to do are very, very specific, that's another way for our industry to attract a broader range of people to come and work for us. And like most of us in the room here, once you know what mining is about, you actually don't want to leave it. That is the gamble that the military bets is, you join us for 3 years and we think we can convince you to stay. Mining needs to do something similar to that. Now I'm going to ask Charles to come up and introduce the next set of proponents. And thank you, Peggy, for shaking us out of our routine way of thinking.
All right, thank you again. Our next speaker is going to be one of our proponents for an approved project, and it's Prairie Clean Energy, Mahmoud Eban Dian, Chief Product and Supply Chain Development Officer. Please come on up.
Thank you very much.
Awesome.
Good afternoon. So I was talking to Charles this morning. This is actually my first mining event. I'm coming from biomass, bioenergy, and biofuel industry, basically producing heat, power, renewable diesel, biodiesel, aviation fuel from biomass. And it's a company based in Saskatchewan, Regina, and that's the place that we have lots of biomass. In north of Saskatchewan, we have forestry. In south, we have agriculture, and the focus of this project is actually on agriculture waste, and that's flax residue. And why we are focusing on this one is, okay, I guess this, okay. So this is, how many of you know that farmers in Saskatchewan, most of them are burning flax straw after harvest season? 1, 2, 3, okay, of course, people from Saskatchewan. So, so why they are doing that? First, there is no use for flax residue. It's a very tough fiber, and it doesn't decay fast enough for farmers to keep it in the field. If they keep it, it's going to be a challenge for the next cropping season, okay? So the solution they have today, the most common, I'm not saying that this is the only one. Some of them, they use a bit of that for animal bedding, which is not, again, the best product for that application, but they burn it. So first of all, it creates air pollution for the farm community. Secondly, it generates greenhouse gas emission. And I want to just give you a perspective of how much emission we are talking about. Every 50 tons, like 50 tons of flax straw being burned, it's equivalent to one passenger vehicle that they generate greenhouse gas emission in a year. That's 4 million tons of CO2. And we are burning about 500,000 tons of flax straw in Saskatchewan. And it's actually a very high value product for the farmers. It has a really high market, so like, flax, because of the nutrition facts, it's a very important crop for the farmers. So they have to find a solution. And so the founder of the company, he's actually based in that region, and he was trying to figure out how we can make a challenge for one sector, a solution for another sector. And that's basically the value for company. And we started in 2020. We are a relatively young company, and we have established a pathway to produce pellets. Why we need to pelletize biomass first is, as you look at the picture in the previous slide, is bulky. You cannot really transport it long distance. It's also, you cannot store it. It's a risk for the companies that they want to use large volumes, so there is a risk associated with the storage. When you pelletize it, it becomes transportable. You can use even rail. We are actually shipping 4 million tons of wood pellets to UK and Japan from British Columbia and Quebec. So when you do that, it becomes like grain. So like wheat, like barley, we are actually exporting lots of this product. So we can use the same trucks, the same storage silos. So we don't need to invest in infrastructure. So that's why we are doing the pelletization, and we have a patent on that process. So the scope of this project is potash industry. And I guess, as you know, that Saskatchewan is the largest producer of potash in the world. And then after that, we have, of course, Russia. It's a very important industry for the province. And we have multinational companies. They are coming, like BHP is a great example. They are coming and investing billions of dollars in the province. We have mining communities creating a lot of jobs. So with this project, we bridge the gap between agriculture and actually mining industry, which is actually, again, that's a strength of Saskatchewan. We have agriculture and we have mining. And later on, we are trying to bring forestry into the picture. And as you know, potash industry, they need a lot of heat for drying, for space heating, and the main source of energy right now is natural gas. And I guess this is a huge risk for any company that they only rely on one source of energy, especially if it's fossil fuels, because most likely, well, I mean, that's the reality. In the near future, fossil fuels are going to become less affordable for companies because of the carbon tax, because of different greenhouse gas emission reduction policy we are seeing. Like, it's not only about Canada, it's about, like BHP is a multinational, it's a company that they have operation in other part of the world, so they have to find solution to reduce their emission. So that's the risk for this company. It's operational risk, that's emission, and also market. Some of the client, they might actually prefer to work with a company that their product has lower carbon intensity. And also regulatory risk. If we never know what's gonna happen in another couple of years, maybe the next government say, look, you have to reduce your emission, even the provincial government. So they have to diversify their energy assets. Or solution, like, it's bioheat. Look, it's not a fancy fuel. That's a challenge we have in Canada. Like, I don't know, for some reason, some of the like industry and government, they are looking for fancy product, but bioheat, first, it has deep decarbonization. We are talking about 80 to 90% reduction. Depends on if you are displacing heating oil or we are displacing propane or natural gas. It's a deep decarbonization strategy, and you can implement it today. We don't need to wait for hydrogen. We don't need to wait for other source of energy to come and help us. We can do it today, and it's a proven technology. Europe is way ahead of us. They are using it for cement industry. They are using it for pulp and paper industry. So we have that opportunity in Saskatchewan and we are using a local resource. So we are not bringing biomass from like other jurisdictions. So just keep in mind that that's an advantage of having this project in Saskatchewan. So again, that's pellet, that's flax pellet that we are producing. This is the scope. So we are working with like 100 farmers in the region, and the goal is to establish a flax straw processing facility. We need to process it. We cannot deliver it to a potash company as it is. It's going to take a lot of space. As I mentioned, it's a fire risk for these companies, and also it's very expensive to transport. So we are going to have, actually, this is the first facility in the world that processes flax straw in commercial quantities. So that's one of the main delivery of this project. We are very lucky to have Saskatchewan Polytechnic. They have a campus in Moose Jaw, and we are going to, well, of course, Saskatchewan Polytechnic, they are going to install and operate the modern biomass boiler. And we have to, like Saskatchewan Polytechnic, they have two goals. First, they want to train students. We mentioned about talent. So we need this talent to operate this biomass boiler. We don't have that knowledge in Canada. We have it in Europe, but not really in Canada. So we need to train a student, and also we're going to use that facility as a showcase. We are working with some of the local potash companies, so we can actually train industry employees to come and run the boiler. So that would be a demonstration project to show that how it works. And then this is the new practice. So we need to have a technology transfer plan. So that's the last deliverable. We want to show to the industry how it's work, what are the risks, how they can manage those risks, and how they can actually accelerate the adoption of the technology. So I mentioned before, Saskatchewan Polytechnic is our main partners, but as I mentioned, we are working with International Mineral Innovation Institute that's based in Saskatchewan. They have members, and also we have already established quite a good relationship with K+S, Potash Canada, BHP, and also there are other associations. They want to see how they can actually use bioheat to reduce their emission. I want to finish my presentation with the fact that I want to really thank MICA for the opportunity. We are bridging a gap between the industry that in the past they never talked to each other. Now, this project is an opportunity that the farmers, biomass producer, and also the potash industry. And by the way, it's not only about potash industry. This is the focus of this project, but we are already talking to other mining industry that they need heat and power, so we can help them to reduce their emissions. So this is the beauty of networks such as MICA that give us the opportunity that brings industry that never talked to each other before and how they can find a solution to combat climate change. And with that, I finish my presentation. Thanks.
Thank you, Mahmoud. That's an excellent example of a technology coming to help the mining industry from another sector. The next presenter is going to be Dustin Angelo. He's also here with Teresa Quick, but he's going to be presenting. He's the CEO, co-founder of Novamera. Come on over.
You able to put it down here too? Or no? Oh, good afternoon, everybody. My name is Dustin Angelo, and I'm co-founder and CEO of Novamera. And I'd like to take the opportunity to thank MICA for their tremendous support. Not only is it funding, but it is tremendous validation for what we're doing. So what are we doing at Novamera? Well, we have created data-driven hardware and software solutions that enable mining companies to surgically extract ore and leave the excess waste in the ground using conventional drilling equipment. So we're not the drills themselves, we're the technology behind it. So essentially the brains behind the drilling. So we've got technologies that allow mining companies to take these conventional large diameter drills that could have cutting head sizes of about 2 meters in diameter and turn them into surgical devices. And so the problem, or at the same time, the opportunity is there's thousands of deposits all across the world that are small scale, they're narrow, they're not economic when you're trying to mine them using conventional mining methods. And when we talk about, and we've already talked about here today, a little bit about the need for more production. Well, these are types of deposits that can be accessed to fill some of that supply gap. But the issue with them is, just as you see here on the left, what we're focused on are these, what's called steeply dipping narrow vein type deposits. So for those that may be not familiar with this, kind of envision an underground theater curtain, long and wavy and deep and very thin. And given their geometry and their orientation, they're very hard to mine economically if you want to try to use like an open pit method, as you can see there on the left, right? You take out a tremendous amount of waste, and it's not very economic to do it in that fashion. Given their size, too, if you tried to do an underground mine, the amount of infrastructure that you need in order to access these small deposits, you just can't justify that cost and amortize it over the life of that deposit. So this got us thinking, what if we could actually just come over top, like you see on the right there, and surgically extract that ore and leave the excess waste in the ground? So you'd have no pits, and you'd have no underground infrastructure. And so that would help unlock a lot of these sort of stranded mineral resources and be able to use them towards filling these supply gaps. And many mining companies have these deposits. They're already known, right? They're within project areas. They're part of mines or zones within them. They're on the periphery of their projects. They're pit extensions. So instead of having to go out and find new deposits, you can access what you already know is there. So this is just another tool and another method, and looking at a different type of mineral resource that's out there already that can be added to meeting that future demand across many different types of metals and minerals. Our technology is agnostic, so we're looking at precious metals, energy transition metals, and industrial metals. And so a great example of this is the Hammerdown mine in Newfoundland, and this is where we're going to have our project. They've got an open pit mine plan they're looking to develop, and then on the periphery of that, outside their mine plan, they have stranded narrow vein deposits that they can't mine. So this is where we're going to be trialing our technology. And just to give you a sense of what surgical mining is, our technologies are enabling this process. So on the right there, you see basically a caricature of a mine plan. And it's essentially these vertical benches, these cylinders that you're mining and moving along the way and mapping those vein deposit in high resolution, close proximity and spacing, basically those cylinders, and then doing vertical extraction. And you kind of do this continuous cycle as you move down the strike length of the vein. There'll be a surgical mine plan in place that you follow, and then you get better resolution as you actually employ the technology. And so our technology to enable all this surgical mining that attaches to these large diameter drills is our guidance tool, our smart drilling systems, and our software. So essentially, we have the technology enables you to see where to go, position in the right spot, and then steer to stay on course. And it's all tied together by our proprietary software that goes from all the planning stages all the way through to production analytics. And so in the field, this is what we're looking to do for our project. We're going to drill and excavate 3 100-meter holes at the Hammerdown site. They'll be about 2 meters in diameter. We will do our imaging, we will do the extraction, and then we'll do the backfilling. So it's that cycle that you saw in the previous slides. What we're going to try, what we want to do is a mine plan reconciliation, be able to demonstrate the accuracy of our tools, show the mining productivity rates, get an understanding of the operational integration issues, look at social and environmental impacts, and then confirm some of our economic modeling assumptions at this point. And we've had some great partners in this project, so Maritime Resources and Memorial University. The logo that didn't make the slide here is College of North Atlantic, so I want to give a special shout out to them since they didn't make the slide. But these are our 3 project partners, and we're always looking for more partners as well. Thank you very much. I appreciate your time and look forward to getting this project kicked off.
Thank you very much, Dustin. Our next presenter is, this is number 16, for those of you who are counting. Telescope with Corey Zan's PhD scientist.
All right, thanks for joining us today. So I'm going to tell you a little bit today about our company Telescope Innovations, which is based out of Vancouver, and a little bit about our project we've been working on with carbon-negative production of lithium carbonate from continental brines. So who are we? Telescope Innovations is a chemical technology company that specializes in scalable manufacturing processes and tools for the chemical industry. So our contract research division in particular is interested in working with mining and engineering service companies to improve manufacturing processes for battery materials. So chemical processing typically involves many steps, especially in the mining industry, to get from your initial input feed to the final product. And our company takes a unique approach to process design that allows us to actually reduce the number of steps in a chemical process. And so the way that we do this is through a combination of process automation, high throughput experimentation, and by also using a variety of online analytical tools that allows us to study a process in real time. And all of this allows us to basically reduce the number of steps in a process, hence the name Telescope. We telescope the process into fewer steps. So this gives us better data, it gives us faster results, and allows us to come up with these processes that are telescoped into fewer steps. So our company specializes in the processes that produce lithium products. In particular, we're interested in lithium carbonate. So 90% of all the world's lithium is currently mined in Australia and in South America in the lithium triangle. But North America actually holds 7% of the world's lithium reserves. So there's a massive opportunity here to actually source this metal locally. So our company works with continental brines in Canada and in the US. We're not really dealing with hard rock sources. But North American brines are actually pretty challenging to purify. So they tend to be pretty low grade in lithium, especially when you compare it to something you would get in, say, the lithium triangle in South America. And they also tend to have high concentrations of impurities, things like calcium and sodium. So our company uses this continuous process that uses 2 reactors, 2 crystallization reactors to tackle this purity problem that's associated with the North American brines. So the conventional process to crystallize lithium carbonate has a lot of purification steps that are required up front. So typically a lot of pre-processing reagents are needed. There's going to be a couple ion exchange columns usually, and this all adds a lot of CapEx and OpEx costs to your plant. The conventional process also uses carbon dioxide gas in this reactive crystallization, which is kind of a secondary purification step that's needed at the end. Our process streamlines the entire crystallization step without any need for brine pre-processing up front. And by carefully controlling the conditions in our two crystallizers, we can crystallize battery-grade lithium carbonate in one shot without the need for this secondary crystallization step. So we're also targeting carbon negative lithium carbonate production. This is kind of the secondary goal of this project. And we're basically kind of have two strategies for solving this problem. The first strategy I touched on a little bit in the previous slide, but by reducing the number of steps and reducing the number of reagents that you need in your process, you can actually lower the carbon footprint of the process as a whole. So reagents that you have to add into your process have production associated with them themselves. So if you reduce the amount of reagents that you're adding, you're lowering the carbon footprint associated with their production and their transportation to the plant. So that's going to lower your emissions in the process already. Also, having less steps means you can lower the operating costs of your plant, and you can lower the amount of energy that's required to run the plant, which lowers your emissions as well. The second and probably more important strategy that we're taking on is by replacing soda ash with CO2 gas as a carbonate source in the crystallization reaction. So CO2 can be sequestered from nearby industrial operations, and then you can put it directly into the process, and it actually ends up incorporated in the lithium carbonate product at the end of the process, hence making it carbon negative. So we have two partners for this project, Standard Lithium and Natural Resources Canada. So Standard Lithium is based out of Vancouver. It's a near commercial lithium development company. And the way that our relationship with them works is at Telescope, we develop and test crystallization and extraction processes. And then Standard Lithium pilots them at their facility in El Dorado, Arkansas. We also work with Natural Resources Canada. So NRCan has been very helpful in identifying feedstocks for us to test on our process. So they give us compositional data from local brines within Canada, and then we can test them in our process. And we're also working with a team of modeling experts at NRCan to help optimize both the purity and the yield of lithium carbonate in our process. So with that, I'd like to thank you all for your time. I'd like to thank MICA for organizing this and for the money. And if you have any questions, feel free to come up at the next coffee break and I can answer.
Thank you very much for the presentation. I'm so happy to see that we are addressing those critical minerals with some of our projects. The next presenter is RIINO, Aaron Lambert, who's the founder and president, whom I met a long time ago when he had an idea on a napkin. Okay, coming over.
Hi, everyone. My name is Aaron Lambert. I'm the founder. Oh, I got it here, but not up here. Oh, no, we got to go back one now. There we go. My name is Aaron Lambert. I'm the founder and president of RIINO, and we're developing our zero-emission monorail haulage system. And I first want to thank MICA for the funding opportunity and the opportunity to be here today. It's been a long journey as a bootstrapped startup. I've been going through a lot of hurdles, and I mean, even today is my first stand-up presentation outside of all the virtual meetings and group presentations. So, I mean, if anybody else there, your nerves are shot today, I know how you feel. It's hot. Okay. So a little bit about our company. RIINO is focused on changing the way we mine with clean, innovative haulage technology for open pit and underground mining operations globally. Our zero-emission monorail is at the forefront of transforming the mining industry with its electric operation and fully autonomous capabilities. With its scalable productivity, zero derailment safeguards, and clean operation, RIINO transports material and delivers each payload efficiently, safely, and cost-effectively. The mining industry is facing large-scale challenges that need to be addressed for continuous progress in mine development and mineral extraction. Our haulage solution addresses mining decarbonization, getting away from the diesel trucks. It focuses on the ESG initiatives by the mining companies today. A big one is the OPEX, the operating costs per ton, moving rock material. If we can't do that at a decent cost, we can't mine, right? Mine safety. We improve the mine safety with haulage equipment. We impact the environmental footprint. We reduce the risks. And another big one is we're reducing the energy consumption on the mine sites. A little bit about our project. RIINO is a continuous load rail system capable of traveling up to 80 kilometers an hour on flat grade with up to 400 tons. And we're also capable of traveling up to 30% grade inclines. And if you're comparing that to diesel haulage trucks or similar type of tired vehicles, they travel 18% grades. Electricity is delivered through a third rail bus bar for continuous power, and the onboard batteries further optimize efficiency and reduce required infrastructure. This allows the opportunity to reduce haulage operating costs by up to 50 to 90%. With a light footprint and a small profile of only 1.8 meters or 6 feet wide, this system is extremely versatile. We've allocated 24 months that we plan to deliver the first pilot, complete from design, build, operational testing, validation, and industry demonstration. Some key factors and a part of the elements of our design include: it's 100% electric, has a complete autonomous operation, it's modular design for simplicity and to have fewer components, it has unlimited surface and underground applications opportunity, it has steep ramp travel, which we can do 30% grade and most likely more than that. We've included zero derailment safeguards. When you're using a lot of rail equipment, there's derailments that stop productivity, so we've included safeguards against that. There's no standby charging time, as you do with other similar battery electric vehicles. It also provides electric power regeneration when traveling on decline slopes. And another one is there's no haulage roadway dust. Our approach to solving the problem: we're focusing on delivering an advanced, low-risk haulage system solution by incorporating a configuration of industry-ready subsystems and a co-development strategy. So as developing new technology to lower that risk of being successful, we want to include as many different components that are already market available and off the shelf. So some of those systems include the electric drive motors, batteries and regeneration, rubber drive tires, the automation controls, rails and structure design, bus bar power supply, and the loading and unloading equipment. Now, regarding our co-development strategy, we have a consortium group collaboration and co-development for technology that is financially and technically de-risked. Consortium steering committee will lead the plan for industry adoption and operational integration with less overall risk, faster development time, and lower cost results. The RIINO system will be developed in a series of phases and stages with operational testing and demonstration conducted in a full-scale pilot environment. The validated RIINO system will next be deployed in a surface mining operation to provide evaluation under a full range of conditions, realized economic value, demonstration of rock haulage alternatively to conventional trucking, and evaluated for commercialization readiness. RIINO has partnered with the Canada Mining Innovation Council, also known as CEMI, with recognition and support towards the continued development of the technology and its potential for addressing material movement challenges in the mining industry. RIINO will be supported in a multi-phase approach, funded and developed collaboratively by 3 Tier 1 mining companies, with the option for others to contribute as the project progresses. The group will ensure the final solution aligns not only with their requirements, but also with the needs of the entire mining industry. So our project facilitator is Rethink Mining, which is part of the Canada Mining Innovation Council. And our project funding and collaboration partners are 3 Tier 1 mining companies, which we'll be announcing in the upcoming months as the project progresses. And for anybody who wants to learn more about the project, please reach out to me and feel free to have a conversation. It'd be great to meet you. Thank you.
Oh, thank you, Aaron. Our next presenter is Imran Megji with RockMass Technologies. Imran, are you here? Oh, there you are. Oh, you've got a unit. There you go. Okay, come on up. Okay.
Thank you. I thought it'd be a good opportunity to do a little bit of show and tell. Nobody has taken this approach today, so I'm honored to be the first. Okay, so just to introduce myself again, my name is Imran Megji. I'm a geology specialist with RockMass Technologies. Let me get that clicker. And so I'm just going to be speaking about some of the automated geological and geotechnical mapping endeavors that we're embarking on this year with using LiDAR and computer vision. Okay. I think it's just lagging a little bit. Okay, perfect. So yeah, about RockMass, again, we're a geosciences engineering tech company, and we're looking to improve some of the productivity, help reduce some of the costs among some of the largest global sectors, including mining and infrastructure. So our bread and butter has been for the longest time the mining sector, but we're kind of segueing into the infrastructure sector as well. So tunneling, a lot of precast concrete projects. And we're headquartered right here in Toronto, so a local product. And these are some of our current solutions. So what we, the laser there. So what we offer is the ability for users to go underground and to be able to actually digitally scan your underground environment using LiDAR. So what we can do is we can capture 3D point clouds and then HD images. You can also map some of these really important geological features. So consider you're in a really structurally controlled environment and you want to really fine-tune some of your models. Because obviously, if you consider some of the drill spacing that's considered suitable for narrow vein gold, let's say, for example, when you get down to that ground, kind of day-to-day level, what you encounter is a lot of variance between what your models were and what you're actually mining. So there needs to be a way, for the geology teams and engineering teams to really quickly pivot and be able to fine-tune their models and change them really dynamically so that you're actually mining the resource as it exists in nature and not just as it exists in your model. And so by capturing these 3D point clouds and mapping things in a very digitized way, this is going to really optimize the workflow of geotechs and underground geologists. So my background was as a geologist. I worked in at the Macassa mine, and now it's run by Agnico Eagle. And so, really what I was focused on was trying to find some sort of time savings within the workflow, because a lot of time is committed to, mapping things in really traditional ways, and then you spend most of your day just trying to digitize things and present it in a way that somebody who's going to be producing a model can utilize that data. And another huge benefit is that the data can be collected from a very safe distance away from your active rock faces. So that's going to empower people to operate a little bit safer. And we all know that high quality data ultimately is going to lead to high quality decisions downstream. Yeah, and so the reason a lot of us at RockMass are passionate is because we've encountered a lot of these problems firsthand from working in the mining industry. So again, I've worked in the mining industry for 8 years. My colleague Sierra was a geotechnical engineer working at the KID operations, and if you're familiar with that operation, one of the deepest base metal mines in the world. And so she was really involved in testing and implementing several LiDAR-based solutions. For the reason that actually collecting data and operating in those environments in that really, really deep, hot, and seismically active environment. It's not where you want to be sending boots on the ground. So they were really testing out several digital solutions. And so she was introduced to the version 2 iteration of our mapper. And now she's comfortably working in Toronto for RockMass. And now she's helping develop some of the geotechnical features and applications. Again, my background is I worked as a geologist in the Macassa mine. And I reached a breaking point in my career. It came to the point where I said, I don't want to transcribe data anymore. I don't want to re-enter data one more time. I just want things to be automated because, you know, there's a lot of reinventing the wheel when you're collecting that data. You know, you're doing it by pen and paper. Then you're going up to surface. Turns out your pen and paper is really wet because it's wet down there. And then you have to dry it out. Then you have to scan it, and then you have to georeference it. And it's just, by the end of it all, you don't really get to actually scrutinize your model. What you're doing is, you know, you're handing in your homework before it's due, and then, you know, by the time they drill and blast, it's too late to change anything. So I started seeking out some of the alternatives to the traditional methods, and I encountered RockMass Technologies. And so, you know, this really fit my narrative. I don't want people to be spending a lot of time collecting tedious data. I want them to be able to collect data in a seamless way, integrate it seamlessly, and then you know, be on their way and develop some really, really good high quality models. So, and that's kind of where this problem arose. There's been this huge digital adoption of CAD-based software. When I started working at the Macassa mine, we were still completing reserves using the polygonal method, just using, you know, pen and paper. We were given, you know, fat stacks of paper, and we're told, you know, come up with the resource estimate in a few months. Obviously now we're using, they're using block models, and no one's really scoped out the, you know, what are the benefits of collecting data in a more streamlined, consistent digital way. And so that's our focus, is to basically empower, you know, operators, mining companies to collect this data using LiDAR and computer vision. And so what that can lead to is increased operational efficiency, again, improved safety, so you're not sending the boots right to the face. What you can do is actually capture the data from a fair distance away, and that would leave some positive impacts on you know, social and human health. So if a worker doesn't feel safe or comfortable in a specific environment, because it's seismically active. I've been in, you know, many situations in my career where I hear a bump and then I'm just, you know, I've turned and I'm running back towards the shaft. And ideally we can avoid many of those situations in the future if we have things more autonomous. So just a quick summary of our approach. At this point, we do have a commercially viable product. You can see the how sort of this development process works. We started out with a prototype. Because of the great industry partners that we do have currently, we were able to iterate and sort of test out the product with these partners. And then ultimately what we do develop are pilot studies and case studies. And then at the end, it results in commercialization. So what you see in front of me is our RockMass Eon. This is our version 4. It's going to be commercially available sometime mid-summer. And currently we have already commercialized our version 3 unit. So again, our focus is to generate these vast geological and geotechnical data sets so that we can really empower you know, some of these high-level decision makers to gather insights and take action in real time. We want to maximize the data interoperability. So that way, you know, if you're a geologist and you're collecting data and you want your geotechnical team to scope out a certain area of the mine that you deemed maybe it's seismically active and you think another set of eyes should be looking at this area, you know, our platform makes it really, really easy for people to communicate and yeah, operate between the data. And ideally, what we'd like to see in the future is to really remove the personnel from the face level. So if you have your autonomous equipment going in, like you have your jumbo drills going in and drilling off your faces, if we can mount a device like this right at on that jumbo boom, then ultimately we can collect that data without actually sending your technical person. So now you're clearing that technical logjam. You don't have to rely on a skilled person to go down there and actually visually inspect the face. You can get somebody else to basically capture that data, and that data can get sent to somebody on surface. And so again, we're going to achieve this through our new version. This is a more ergonomic version. We call it, we say that our unit went through the weight loss program. It shrunk its weight by almost half. So that was a suggestion that a lot of our industry partners had given to us in the past, is that they don't want to lug the equivalent of a 12-pack of beer in their backpack as they're going underground every day. So we've reduced it to about a 6-pack now. And we want to strengthen some of the software partnerships. So we have great partnerships with Sequent, with Deswick. In the future, we're going to start to develop some APIs so that when data is captured underground, you can quickly just move it into our cloud software. And that way, using an API, you can just import it right into your Deswick or your Leapfrog project, and you can quickly work on that data. Okay, and just to summarize some of the projects that we're working on. So I did a little demonstration at the CIM, just talking about how you can use this LiDAR-based technology to capture underground geological data. The idea was to use this data to integrate it into a dynamic grade control model. So what you can see here is, oops. Oh, can I actually go back? I'm sorry, I meant to use the green laser. Thank you. So what you can see here is the annotations that I provided on the face. That was when I was underground. I did that on the mapping interface. And what you can see in green is what the model used to look like. And just with a few clicks of a button, because it's a dynamic model using post-processing software, all you have to do is input these annotations, and now your model is dynamically updated. So if you want your mine planning engineers to now act upon the new positioning of your resource, and you want them to develop a drift or develop, in this particular example, this was discussing a narrow long hole. And so you can see in the green dashed lines, that's what the model used to look like. And just based on these inputs, just from day-to-day face mapping, we were able to update the model rapidly and then provide this to our engineering department so that they can now plan based on this new data. Now, one of my colleagues, Josie, she's been working on developing a machine learning algorithm. So essentially, this is the input data. You're going to be annotating tunnel cracks using the mapper interface, and then basically using the RGB inputs, you're going to target the crack locations, convert it into binary values, and then essentially this is what your output will look like. And so you're going to be training it to recognize these cracks. And so you can think about the applications now if you're a geotechnical engineer and you're underground and you want to rapidly identify joint set orientations, you don't need somebody to interpret that data underground. You just want them to take a snapshot and then move on. This sort of algorithm would empower them to do so. And similarly, another colleague of mine, Sierra, is working on understanding the lowest reliable detection threshold to basically characterize ground deformation using our mapping solution. And so essentially, pretty straightforward. Oops, I pressed the wrong button again, I'm really sorry. Essentially what she's been doing is using foam blocks just on a poster board and using our LiDAR technology to map out these foam blocks and understand what's the minimum threshold for detecting any variance. And so ultimately, the use case for this underground is if you're in a really seismic area and you wanted to maybe characterize the swell or maybe subsidence of your back, or maybe the walls are swelling. This is a way to also help characterize that. So really it's giving geotechnical teams a very, very valuable tool to help characterize their environment. And just some of our partners, again, thanks to MICA, it's really helped build some really good quality partners. So Newcrest, the Bruce Jack mine in northern BC, with New Gold, the New Afton mine, So we've had some great back and forth with these partners. They've had some great feedback for us, and our technology partners include Sequent and Deswik, and again, with the UBC with some of our machine learning. Okay, that's it. So thank you for your time. Appreciate it. And again, once again, thank you for MICA for all the support. Yeah, and if you have any questions, feel free to talk to me in the coffee break too. Thank you.
Okay, thank you for that. Our next presenter is going to be Expeto, and I would like to welcome up Michael Anderson, CEO.
So hello, everybody. I'm Michael. First of all, thank you, as everybody said. You know, in my experience, innovation is a team sport, right? As they say, it takes a village. It's kind of a fun village to be a part of, right? Hearing all this today. So with that in mind, I'm going to talk about our project, which is seamless handover of disparate networks for autonomous vehicles. Now, we've all heard of 5G, right? You can't throw a Frisbee this day, right, without hearing about 5G. The speed, the reach, the scale, right? Hundreds of megabytes per second, 10 millisecond latency, right? So when we talk about autonomous vehicles, teleremote drilling, we think about sensors, right? This connectivity foundation is really, really exciting. But there's kind of a problem, right? And if we look back at, let's say, Wi-Fi, which a lot of minds have really used ubiquitously, is Wi-Fi is like really familiar, right? It fits in an IT workflow. It's on our network. It's our IP addresses. It ties in with our security, right? Pax familias. It feels great, okay? And 5G is weird, right? It uses a bunch of like telco type acronyms. None of the IT people get it. If you want to bring a vendor in, you got to fly to Scandinavia, and bring in one of the options there, and they kind of work in this little corner, and they really don't tell you what they're up to, right? And so, we think about innovation, it really should be about seamless integration to what we're doing, into our workflow, right? But as vendors, we kind of get a little bit excited. And we have a tendency, like Shakespeare said, the play is the thing. Every vendor's like, hey man, the 5G is the thing. The AI is the thing. The compute is the thing. The drill is the thing. The LiDAR device we just saw is the thing, okay? But from our perspective, as we think about our role in the mining community, what our responsibility is, right, is to really build a connectivity foundation, right, that's abstracted, that's useful, that's familiar, that seamlessly integrates, right, into the workflow and IT systems of the mine. So when we talk about Expeto, we're about enabling 5G, not a network, but networking, so you have that foundation, okay? And what that means from our perspective is that, first and foremost, seamless integration with your IT systems. A key part of our platform goes behind your firewall, your IP addresses, your security, your control, right? We think about an autonomous vehicle. How many people know how many VLANs are on an autonomous vehicle? Minimum of 6, right? IP, right? Not 5G, not cellular, right? But this is IT networking. And so when you think about our perspective and how we engage our customers, in as much as we'd love to make the conversation about 5G and the network, we don't want you to care. It doesn't matter. We've done our job if it doesn't matter. We've done our job if we're enabling outcomes, right? You can't go to your management and say, hey, look at that AI, right? Look at that 5G. Look at that teleremote drill. Give me my bonus. No, right? It's about safer. It's about more reliable. It's about more efficient. And so what we need to do as a community, as that village, is come together, right, and force these new technologies and force the innovation, right, so everything works together easily, okay? So as we think about kind of existing options in the problem, how many people played with Legos as a kid, right? Okay, so, I grew up kind of humble, and so I had Legos, but I had Connects, I had Mega Blocks, you know what I mean? I just kind of had this smorgasbord of stuff. And I didn't spend my time creating. I spent a lot of time integrating and duct taping, right? That's not what we need to do. We need to put our effort into outcomes, right? Not integration, right? But driving businesses. And existing options, especially in cellular, are really hard. Like I said, they're weird. They don't play nice with other things. And so what we did initially with LTE, right, is we really focused on this open, API-based, IT-centric solution, yet with no compromise on the speed, reach, and scale of cellular, right? That mission-critical attribute, okay? So as you think about some of the attributes, we've focused on IT plus simplicity. We've focused behind the firewall control. We've thought about not just one mine, we've thought about 5 mines, 6 mines, the corporate office, the trucks on the road, and creating this single WAN, right, with a single pane of glass. Everything's on the network, everything's tracked, everything is then an application work plane. So whether it's an autonomous vehicle, a teleremote drill, a LiDAR device, a truck on a road, a connected worker, a video, it's all on your network. And as a matter of fact, you can create templates, and you can say, hey, up at Agnico where we're deployed, copy, paste, deploy, right? Nutrient mines, underground where we're deployed, copy, paste, deploy. Everything happens in that manner. So as we looked at this opportunity, we said, okay, we did this with LTE, right? Doing great, TRL9, let's go 5G, right? Let's go really big. Let's go gigabytes per second. Let's go with the lowest latency, right? Let's really, really enable this community to do big things. And that's exactly what our project is about, is first and foremost, we're going to have support for all 5G radios. We're going to support 5G. We're going to support NB-IoT. We are going to work with vendors in terms of all these mission-critical devices that you want to deploy in your network. And the UI is just going to be easy, right? It's like your remote control, right? Remember the ones from the 80s? You're like, what the heck do I do with this thing? No, this is going to be so intuitive, so easy, so you can focus on the outcomes, okay? So that's what we're all about. So at the end of the day, there's a lot of complex things happening, but the network is not the thing, okay? The network is the enabler, right? So we want those Lego pieces to come together seamlessly. We want you advancing your innovation agenda, and we want to point to results of safer, more efficient, greener, more reliable, high-performance mines where we're attracting the very best, right, of the workforce, whether they're at the mine or whether they're remote, to bring this together and really advance the community. So with that, we look forward to the next couple years of achieving greatness with this community and really appreciate the time, and thank you again to MICA.
Very good. Thank you for all the speakers and for all of you to stay on track, on time. We will have another speaker in a few minutes. But before we go any further, I wanted to make sure that we actually recognize who actually put all this together, because it wasn't me. I just stand up and give occasional speeches, so does Charles. The people that put this together were Diane Lepage and Sherry Greasley. So these are the people who were up till 2 o'clock this morning making all of this happen. None of this happens because Charles and I pull levers. It's Sherry and Diane who make all of this happen. So thanks very much for appreciating them. I'm now going to call on Dr. Terry Peckham to come up. He is the Director and Research Chair in Digital Integration at the Sask Poly. And this is all about the Center of Excellence for Digital Integration. So you've just heard one integration story. Hopefully this is the other piece. We were very happy to support DICE in getting their funding some time ago. And now they're rolling along very quickly, and we're trying to catch up. Thank you, Terry.
Okay, it says big green button. Let's see if this works. Do I actually? I have a doctorate, and I'm stuck here trying to do this. I'm a doctorate in technology. This is going well. I have to do something else? Yeah, 21, you got to go back. Go back to the SAS Polytech 21. That's why we're having a problem. He can't find me. We actually thought Ian was going to present first, and then I was just going to go right after him, which would have been like a nice seamless, and then SAS Poly would have been done. So while he is setting up the slides, a little bit about who I am, what we do. So I am what is known as a Technology Access Center. I am funded by the National Science and Engineering Research Council of Canada, NSERC. And my job is to take all those great inventions in the university and bring them into the business world as fast as we possibly can. My focus is primarily in the digital sector. My training, doctorate's in AI, but we're a team of about 50. So we cover a wide spectrum, and you're going to get a chance to see that once he gets the slides loaded here of where we go. Our focus is in the mining sector, because that's a very large play in Saskatchewan. It's also in the agricultural sector. But we don't just play in Saskatchewan. I have companies that I work with in Vancouver. I think I'm doing political analysis out in Vancouver. I'm doing AI video games in Toronto. I'm doing oil refinery LiDAR mapping in Montreal. I am doing, what am I doing in Calgary? I'm doing something in Calgary. I can't remember what I was doing in Calgary. Anyways, the gist of it is it doesn't matter where you are across Canada. My job is to come alongside you. I'm a government employee. I don't make any money other than what the government pays me. But my job is to help you guys as companies make money. And so we take a little bit of what you have. You have to put some skin in the game. We take a little bit of that. And then we apply for some federal grants and we multiply that. So MICA has a wonderful ratio of about, 60-40, somewhere in that neighborhood. I'm closer to 1 to 5. So, but federal grants stack, just in case you're wondering. Just because you got MICA funding doesn't mean you can't come along and talk to me. Maybe we can take some of that money and go a little bit further with some of those things. Are we good to go yet, or is he still trying to find? No, he hasn't found me yet. So I'll just keep going because I only got 20 minutes. All right, so where do I work? Oh, this is getting complicated. Let's do the mining stuff first. In mining, some of our areas of expertise we've come across already, LiDAR, autonomous on-ground, autonomous mapping, I guess, not autonomous mapping, autonomous movement of quadrupeds carrying LiDAR units moving into areas of the mine that are at risk for humans. So we played in some of that space already. We work in municipal infrastructure mapping. Oh, we're getting there? No, we're not. He's still looking. Now you got to go to slide 21. That purple one. Now let's try the green thing. There we are. Okay, so I guess I should go back. So what do we do at DICE? DNA. We play with data. I don't care where the data comes from. It can come from a specific device. It can come from a database. I don't really care. It's data. Obviously, data has to be transmitted from wherever that data point is to wherever I'm doing the analysis. So networking is a part of it. And of course, then the analysis. Sometimes we use AI. Sometimes I use something called statistics. I don't care. Some PhD somewhere else has come up with a wonderful paper. I read it and go, ooh, that looks like fun. And away we go. And we try to implement that model. So just to give you some things. This is not to show you, what this is showing you is that there's a lot of breadth, but what I have found very interesting in my career is that solutions in one sector a lot of times transfer over to another sector, quite interestingly. And so we're in the education, we're in industry and construction. I'm in the fashion industry. So, you know, all sorts of places you can go from. Cybersecurity, encryption, government, municipal, politics, and of course, agriculture and mining. All right, so optimization of the actual mining process. I've got a case story we'll get to in a few minutes. I'll walk you through one example. AI does work. So and a lot of you had barking up sort of the right trees, so that's good to know. Where else am I going to? Ore concentration, hyperspectral imaging. How do we analyze the actual content coming off before it hits the mill for analysis? Underground positioning. How do you position in a GPS-denied environment accurately? Currently, a lot of things are using LiDAR and lasers for surveys. Is there a lower cost way of doing that and at the same time enabling transmission of data? The answer is yes, especially if it's a low cost and you can throw it away. 4G underground wireless transmissions. I don't know anybody here, but if you've played in certain mines, the transmission of a wireless signal through a mine has all sorts of ramifications. In hard rock, welcome to the world of multipath. In soft rock, well, actually, it will carry. So some of the signal gets carried in the actual ore body, which is one of those interesting facts. Just one of those things. Mines tailing risk analysis. Been in that space. And then confined space analysis, I talked about using a quadruped with the LiDAR unit mapped on top of it to go looking for things underground. So, okay, so mining space. Let's talk about a very specific one here. Cameco is one of our clients. The only reason I'm going to talk about this is this was actually cleared for proof before we kind of went through and did things, so the stuff has already been set up for publication. So this is actually a really difficult mining problem. Cameco Cigar Lake Mine is the only one in the world that well, it's not truly the only one, but it's one of the more important ones that uses the jet boring system in their high-grade uranium ore that exists out there. Basically, we're going to take water and we're going to cut the rock ore with it. So we're going to blast it with water rather than explosives or any other device. Again, it's highly radioactive, so we can't put a person in there to get it out. One of the problems, the ore body happens to sit in the middle of an underground aquifer. So we might have some problems, and they have. So, I said go. There we go. Discovered in 1981, 217 million pounds, 450 meters below the surface, hydrostatic, so it's actually got some wonderful pressure there. And they have flooded many times, by the way. So it's not like the flooding wasn't, it's a known issue. They have flooded a few times in some different mines. And of course, it's all radioactive, so you gotta be careful with the human contact, so that's getting water. So what do? They drill a tunnel in the base rock underneath, come from underneath, they drill a hole, well, actually, it's actually in a fan shape, to be honest with you, but you drill a hole up underneath, send up a water jet after it, and you start cutting the rock out. And of course, you mix the water with the rock, you get a slurry, and it flows down through a lead pipe, drops it into a car, takes that car across, drops into the slurry. It's pretty much straightforward, you would think. Of course, no problems can exist in that particular scenario, right? You've got a wonderful cavity that's cut by rock. So some of the resulting shapes, well, some things, sometimes it goes exactly as planned. You're actually able to cut a fairly good cylinder. Now, they cut these cylinders beside each other, so actually the shape of the cavity makes a difference, because number one, you don't want it to cave in on itself. If you cave into it, then trying to cut the cavity right next to it doesn't really help you out a lot, because you've got a lot of loose material there. You can end up with sometimes a apple core, which generally means you had way too much water pressure and you just created a giant balloon, which makes your next shape beside you somewhat tenuous on whether it's going to survive or not. So that means you have to leave ore behind to move to the thing, because you want to make sure the next ore body's safe and it doesn't collapse on it. Sometimes you have the opposite problem. Uranium is hard, and we apple core, which means we're leaving our real good stuff in behind. Sometimes we balloon. Oh, sorry, ice cream cone. Ooh, yeah. Nice gravel-bearing pile right above the top of the ore body. And one of the things that Cameco has done, very interesting solution, smart people, they froze the water. So they put a couple of nice cores down, froze the water for ourselves. So we're working in a frozen encapsulated environment. Problem is we're using water under extremely high pressure to cut rock. That creates something called heat. And heat has a wonderful thing about water, it melts it. And so what you have is that gravel stuff dropping down from the top onto your mining process, creating kind of an ice cream cone. I talked about the balloon already. And then, of course, there's the odd time where you hit a clay seam. And clay just doesn't have the resistivity to high pressure water that rock does. And so you have this weird wonky blowout that goes right down the side of the thing. So those are some of the problems we face. So we have core samples. Every last mine has those. What do we do with those core samples in mining? Leapfrog, Vulcan, I don't care what you do. You pick your, you put in your seismic information, your geological information from your core samples into the software package. The software package does this wonderful job of guessing at what is in between those two particular core boreholes. Then they perform the mining task based on what that guess is. Then once they've done that, they actually analyze the resulting cavity. So they actually send up a LiDAR unit after they've done it, do a quick scan of the LiDAR. Why? Because they want to know the shape before they drill right next to it. What did we end up with? Can I actually drill right next to it and keep the ore coming out? And then when they're done, they refill the cavity back in with the waste. That's fantastic. So they don't actually have a lot of above ground waste, but of course, you don't really want to store radioactive waste above ground anyway, so let's put it back into the hole where it came from. So their question to us was very simple. Can we use AI to improve our mining process? And everybody says, oh, yes, it can happen. And of course, as you heard already today, well, sometimes it is, sometimes it isn't. So we started by gathering data. For those of you companies that are not yet working with mining companies, they have lots of data. It's often siloed in different resources, and those resources don't always talk to one another. And so getting a coherent picture of the data took us 2 years. So for you guys that are starting the process, just be aware it can take some time to get that data that you need to do the AI that you need to use to get the results that you're looking for. We prepared the data for the AI as much as you would like. In the real world, data is messy. It's never clean. And they have data that's been going for years. So they have years and years of data, and they change techniques for how they collect the data, all sorts of wonderful things like that. So we have to spend some time cleaning that data. The next one, for some of you guys that are working with mining companies, most mining companies have all of the compute resources they need to have in order to have operations work successfully in their company. What they don't have is a lot of spare resources, because that costs money. So they just don't have massive amounts of spare storage. And so what you end up having to do then is finding a place to store where the research is, or the interactions you're going to have take place. As a company, they're not going to give you the data. You can ask for it, but they're not going to give it to you. So they're going to want to maintain control of that data at all times. And so then what we're looking at is how do you create a hybrid cloud environment where the company is still in control of the data, but they will give you access through their systems to that data. And they maintain control of that at all times so that it doesn't go anywhere at all. Well, being a researcher, we just figured, since we got the data, let's see how many different algorithms can we run on it, just to see which ones turn out the best. And we work our way through this in an iterative process. So we run the AI algorithm, examine the results, and then we re-examine the data to find out, well, why didn't that work the way we thought? What are we missing? And we went back and forth through that nice little cycle as the iterate kind of happens right there at the bottom. So what were we able to achieve? Yay, 6.7% increase in production. Does it seem like a big number? That's within what the literature says I should find. The literature says between 5 and 10%. Nice. Cameco does 2.8 billion per year. Now do the math. There's a rather significant number that's attached to that. And actually, that's the low number. There's better numbers out there, but again, there's always other factors that kind of happen inside that increase in production. Decrease in waste was another side effect. We were actually able to not take as much of that gravelly stuff on the top. We were able to take more of the true actual grade ore very accurately. The other part of it was we were able to do it with less energy consumption. So what you guys are all trying to achieve in this one particular case example kind of proves the point of where you guys are all going. This stuff works. The different approaches you guys are all looking at taking, it works. It's not fast. It's not always easy, but it works. We're only just getting started, though. That's a simple reality. This is a long-term process. Continuous model improvement. Oh, I think I've heard a few companies here that are looking to do that kind of stuff. How do you take the data that we've already gathered from the ore production? How do we then turn around and feed that back into as a continuous loop back into software like Vulkan, which is actually part of your actual model? You're just creating the block model for your mine plan, and you update your block model. How do we predict ore results for the milling process? So some of our results are already are able to pick out what are some of the nasty chemicals that are coming out of your production. So for example, in uranium mining, arsenic is one of the nasty side effects. We're getting to the point now where we're able to actually predict arsenic output, which means the milling process, which comes right after the drilling process, is able to adjust their processes to handle the arsenic output. And the last one is, how do you standardize the data? You're gonna find out that a lot of these companies need a little bit of help with standardizing their actual data models. They're still fairly young on a lot of this stuff. A lot of the data has been generated over years. It's siloed in relational databases according to levels of expertise, which was standard practice. But that doesn't allow you to integrate the data smoothly into one large set seamlessly, so you can actually do much more advanced analysis. The companies are interested in those types of things, but they aren't there yet. All right, thanks for not falling asleep. And for being patient while we set up the slides. Any questions or just get us back on track, I guess. That's all I have. Thanks, guys.
Thank you, Terry. That's fascinating stuff. And thank you for being so great at extemporizing without any slides. Many of us would just be poleaxed without the crutch of our slides. And I'm one of those people. Anyway, now it's my pleasant duty to invite Kyle McCall to come up and introduce the next panel. I hope Kyle is here. Where is he? There he is. There you go. Kyle McCall from MICA.
All right, good afternoon, everyone. I've got the benefit of hosting a panel, so I actually don't have to mess around with the remote, so I'm looking forward to that. As Douglas mentioned, my name is Kyle McCall. I am the Director of Commercialization Services and Member Relations. I recently joined the CEMI team. I actually recognize a lot of your faces from a video screen, so it's been great to be able to connect that way. Hopefully, we're able to connect a little bit more over the course of the last kind of couple hours here remaining. Looking forward to having those conversations with you. If you are a MICA member, definitely get in touch with me. I would love to know what you're up to and how we can support you more fulsomely. But that's not exactly what I'm here to do today. I've got the pleasure of hosting this panel featuring a couple of our SMEs this morning. So I'd like to welcome to the stage Dustin Angelo, the CEO of Novamera, Francois Doucet, the CEO of ELEMISSION, and Zac Young, the COO of H2nanO.
Thanks, guys.
All right. So we have had the benefit of already hearing a little bit about Novamera and ELEMISSION. So to start, I'm going to give the floor over to, do we have mics? Yeah. Oh, thank you. I'm going to give the floor over to Zac just to give us a quick 2-minute rundown of H2nanO, so we're all kind of starting from the same point here.
Super. Yeah, thanks, Kyle. Hey, everyone. First round investee here, so get you caught up really quickly. H2nanO is a water treatment and emissions reduction company focusing on nature-powered technologies. So we have a sunlight-powered treatment process for mine-impacted water and tailings. We use that for oil sands, tailings water, as well as some other mining applications, treating organics and metals from that water. So our project is in flight right now. We have some work going on currently in both our locations in Kitchener and Edmonton on this project, and with some success towards reducing some of the naphthenic acids and other contaminants in some of that tailings water. So, yeah.
Awesome, thank you. And so the nature of the panel today, too, the conversation that we're looking to have is about bridging that innovation gap. And of course, to start with bridging the innovation gap, we first have to identify a gap. So maybe starting with you, Dustin, what was that aha moment? You know, we're onto something here. This technology allows us to do something interesting. How did you arrive at that point?
Sure. So for us, we're actually born out of a mining company where we had this problem. And so this was out of necessity that we were looking to find a solution. And so I was the CEO of a mining company called Anaconda Mining, a gold producer out in Newfoundland. And we had an open pit operation that was fairly low grade. And we were looking for other areas around our property to be able to add production, extend mine life, all the standard problems that mining companies are trying to solve every day. And we had a deposit that was about 1 kilometer from our mill and from the operation called the Romeo and Juliet deposit. And it was, as I mentioned before, this steeply dipping, narrow vein type deposit. And we couldn't mine it using conventional methods. So we tried to put pit plans around it, open pit plans around it. We tried to go underground. Nothing would work on paper. And that's when we decided to look at a different way to mine this. And along the way, my business partner, Alan Cram, who's one of the co-founders of Novamera, he was the general manager of our operation out there. So he was literally in our open pit. And in our open pit, you could see the blast holes from our operation, and you can see that they were kind of deviating. And that was his aha moment, be like, well, why can't we use drilling and directional drilling and sensor technology to be able to locate and then surgically extract this ore? So that was kind of our first aha moment. And that's when we started to work with Memorial University to be able to create this, to kind of germinate this idea. And then we took this whole idea to Disrupt Mining in 2019, and we were one of the finalists. And we didn't win, but when we got off stage, there's about 500 mining professionals in the audience, and we started talking to a lot of them, and they thought that the technology we were creating would be applicable for them at their mine sites. And that's when we had the real aha moment, because we went from thinking this was just a problem we were trying to solve for ourselves to now one that was actually a problem that was pervasive throughout the mining industry, because these companies had projects all over the world. And so that's when we pivoted and decided to spin the technology out of Anaconda Mining. That's when we created Novamera. So that's kind of how we got to where we are today and why we're working hard on this.
Yeah. It's always nice when you've got a room full of mining professionals to validate an idea.
Exactly. Yeah.
Maybe Zach, your aha moment.
Yeah, for us it was maybe from a different direction, the lab to the field. We had an industry challenge, specifically one that was looking for a treatment for this mining process affected water. And that started as a moment that was taking something that was more developed for drug delivery and targeted delivery of nanomaterials and translating that over to an environmental application and some of the technology we use to do that treatment. And then with that, some progressive validation and partnership with Canada's Oil Sands Innovation Alliance, COSIA, which is a great testing ground for us to get relationships built with the mine operators and be able to prove through a milestone-based program how it was working at each successive scale of graduation up to field scale operations.
Right on. And Francois, I know we were chatting a little bit at the table. You've got a bit of a different approach to industry as well, having coming from NRC or NRCan. So curious to know how you arrived at ELEMISSION.
Well,
Just give it a sec.
hello? It works? Oh,
Yeah.
okay. Well, in 2014, we decided, to jump definitely from NRC to a startup. We kind of close our eyes and jump. We had a business opportunity that was more in the metal sector for recycling of aluminum alloy. So we developed a sensor that is made to be installed over a conveyor belt, which could be useful for the mining industry also. But in almost 15, we had a conversation with the person that worked for a hyperspectral imaging company that were maybe a bit early, that disappeared, and they kind of challenged us by seeding this idea of bringing laser ablation atomic emission spectroscopy as a drill core scanner. So it's early as 2015, we start to put the building blocks of our probe, and we had a idea to eventually bring that to a large scale, fully automated laser ablation spectrometer. So it came out in 2020.
Working on. And of course, you know, one thing is identifying the gap. The next is obviously doing something about it and getting it to a point where it is ready to be commercialized. And all three of your organizations, your companies, you are in various pilot stages or getting close to commercializing. In some cases, you're in market. But you know, we use this word a lot in industry, commercialization, especially as innovation centers, commercialization. You know, Dustin, what does commercialization mean to you as an SME?
Yeah, it is somewhat of a subjective term, but for us, I mean, we're at this point now where we're actually demonstrating our technology in the field to mining customers. So we're not quite to what we would consider commercialization, but for us, it would be getting to the point of having our minimum viable product ready to go, which we think is going to happen in the short term. You know, understanding that product market fit, finding those early adopter customers, you know, and starting to generate revenue, right? And you know, it's sort of the launching point before you really can understand and start to scale.
Yeah. Comments or around
Yeah,
commercialization?
I would say that a sector like mining, one of the things that I've picked up through the process of being in, you know, startup programs that have talked about really fast to market stuff that's maybe more targeted towards you know, consumer products, things that have a lot of high turnovers, you know, get in market, fail fast. Well, when you're building a field pilot, don't maybe only get 1 or 2 shots at it, so you want to make sure it doesn't fail. So I guess in that respect, like, you know, commercialization is, I think, getting something that's a reliable in-market solution that you can repeat and know is going to be sort of your base level product. But there is a significant portion of the growing up part for us that has been, you know, being adaptive to each season of that scale up, being ready for smaller scale scientific testing to things that are now more field services oriented and deploying the technology and having taken the benefit of those stages as a mechanism to generate some revenue and grow the business without having to be, you know, immediately a leap to that full commercial system. So.
Francois?
So commercialization is probably one of the trickiest part of growth of a company. It initiates growth and it's special because especially for us it was very difficult because the problem is that the existing technology that many dual core scanner use at the moment are well known and the geologists learn them in school. So it's very hard. They don't learn libs at school. Maybe they start to do it, but a few years ago, nobody in geology was learning libs at the university. So we had to do a lot of teaching by, you know, publication of peer review paper to show that we compare to these technology, and then those are building blocks of our foundation of our company, and that's the way we did it.
A lot of education. Yeah.
Yeah, definitely.
Now, and there's that saying in mining too that everyone's in a rush to be second, right? When it comes to adopting a new technology, and I'm just curious to know what has been your experience, you know, overcoming some of those conversations in order to get your technology commercialized.
Yeah. May I? Okay. Yeah. So the thing is, you have to find an innovator somewhere because. When you build something new, if there is nobody to buy it, it's only an invention. But if somebody start to buy it, you have an innovation. It's when you find this champion in a company that believe that your technology is worth it to try, it can go pretty fast.
Zach, any comments?
Yeah, 2 things, I guess. One, the difference between interested and invested. I guess having companies that are willing to participate in a monetary way and in its progressive development and understanding that there's a value in what you're doing for the initial tryout of that technology. And then the second is to just get everyone who wants to be second in one big consortium where they share the risk, which, you know, has worked to an extent for us that we've had some collaborative partnerships where we've had joint industry projects where that risk is shared across a group, and that from that perspective, the mine operator sees that as potentially a lower risk on their capital invested on that testing, and that there's some sharing of the knowledge there. obviously aided by an industry network, that's the framework, but it's worked quite well for us getting this started.
That's right. I imagine there's a lot of conversations, though.
Yeah, well, dealing with 3 different legal departments for a contract is more than the one that you wanted to. But yeah, in that respect, it can be very helpful, though, in terms of having a bit more open dialogue of what each different operator needs and the variability you can expect. So
There's certainly a learning opportunity there for sure.
Yeah.
Dustin?
Yeah, I mean, we've used consortiums as well. I mean, that's a good way to go to be able to spread the risk, spread the cost. I think for us, is we're kind of learning this journey about how to get these folks to not think about being second, but being first. Is, there's probably 4 key things that we try to convey, and this is sort of more of a collaborative partnership type structure where at the end of the day, you've got to get the mining company and the people on board to understand the value that you're creating, right, for them. And what's the applicability? That's a key thing. Like, how does this apply to the mining company? What are the risks that they're trying to mitigate in employing and deploying our technology? And then, what's the disruption, right? That potential disruption to the current operation. These are sort of the 4 pillars that we see that are important to be able to convey and work on with the mining company. These are things that you're just not going to answer this for them. It's kind of this journey that you go on with them to be able to ultimately answer all these questions. And if you can, presumably by the end, you're going to get to the point where they're going to want to commercially deploy your technology. And we do that in kind of a stage gate approach as well. So we've put together a kind of a memorandum of understanding that lists out all these different milestones and takes them through that journey. So it's important because it gives them an understanding of where we are today and where we want to get to, and so that they can see all those steps in advance, as opposed to and adding to it like all the objective criteria to say whether you've actually fulfilled that milestone. And then so there's no doubt about why we'd move to the next step. And it's also important for us because what we've encountered a few times already is our champion leaves. And then now you got to start all over again. But if you have this document in place, it helps to kind of keep the process moving forward. And if you've got all that in place, then you can you can kind of bring them through this journey, and it does help to kind of get them to be more comfortable about adopting new technology and going from second to first. So that's kind of what we try to do.
Appreciate that. And there does seem to be a bit of a theme from today of some of these projects being orphaned just by virtue of the ambassador or the champion that the mining company leaves. So maybe there's something there for the mining companies to take away too, is you need to have a bit of a succession plan in place if you're going to take on some of these projects with these smaller companies with innovative technologies. Sticking with the theme of commercialization, you all also have intellectual property. You've gone down the path of protecting your IP. So curious to know, what role does the IP play in your commercialization strategy, and why did you pursue it as a business strategy in the first place? So why did you make the decision to protect your IP? And maybe Zac, we can start with you.
Sure. Yeah. So for us, I think it's maybe an interesting case study and some stuff that makes sense to claim through a patent. Composition of materials, methods, and how we're designing and developing the process or implementing the process. I think there's a healthy balance there in terms of what stuff makes sense to patent and sort of under the framework of invention that you're looking to specifically protect and potentially through legal means, whereas some stuff is trade secret or knowledge that's invested into the company with time, and making sure that we're tracking and monitoring that stuff too in terms of where it may make sense to transition that to a patent at a later point, and just navigating that. But fundamentally, from an investability standpoint, I think it's important to consider having those assets as a part of your company, and it is important there. But at the same time, navigating also how IP is going to be set up in terms of your background working with a mining company or someone who's maybe participating in the development journey too, where that stuff is maybe potentially shared, or that you need to set some groundwork on what was prior art versus what came out of the project.
Yeah, like you said, the patent is very interesting because it gives you the freedom to operate. So after that, you're kind of t'as l'esprit tranquille pour travailler, so you're free to operate. However, patent teach how you did it. So that's sometimes something that you have to take into account. And like Zac told us, the trade secrets are very important. So some of these ideas and apparatus or process that you have developed might be kept as trade secret because you will slow down your competitor getting where you are. But as you know, I will keep the patent for simple stuff and also for the apparatus.
Yeah, I mean, I would kind of echo a lot of the same points here. It is for us, it's about defensibility and differentiation. We kind of look more broadly at intellectual property to create a defensibility plan. So it's more multi-layered where patents are certainly an important part of that. Trade secrets in our algorithms. All the data that we're collecting in the field, like the data we're collecting is first of its kind. And so it's sort of that, it's kind of akin to first mover advantage. So if we're out there, the more that data we can collect, the more we're out in the field, then we're continually staying ahead of the competition from that standpoint. And then also in our business model right now, we're looking at ways to ultimately that you'd have long-term contracts. So trying to defend the entire business in our service offering. So it's really a multi-layered approach to defensibility. And then I think Zac kind of touched on it a bit. From our standpoint, we're venture capital backed, and venture capitalists love patents, right? So they love to see patent portfolios. They feel that that's sort of the kind of the be-all, end-all when you're talking about intellectual property and defensibility of your company or technology. So from our standpoint, it's almost like a requirement. So you have to kind of balance that, and there's a cost to it, right? These patents aren't cheap. There's the initial cost for having to apply for them, and then you go through different levels of the application, and then you've got all your maintenance fees and things like that. So like if you start to add up these, it can get to be very costly after a while. So you have to be kind of judicious about which ones you select and why. But it's kind of that whole kind of thought process around it. It's financial and investor driven, and it's also just operational and competitive driven as well.
Great answers. Thank you, gentlemen. So thinking about that, commercialization, IP, all that kind of stuff, and now you're actually at the point where you're almost ready to close some sales. So what has been your approach to, knocking on doors, developing new relationships? What does the business development process look like for not startups by any means, but certainly new entries into the mining sector? Let you guys sit on that, or yeah, go ahead.
Yeah, for us, it's been mostly direct, right? So we've been, coming from a mining company and myself having about 20 years of mining experience, and my business partner as well having a lot more experience than I do, we just have a lot of contacts and connections. So, we started off a couple of years ago with just the direct marketing and talking to folks, going to conferences and seeing people, and just generating awareness. So a lot of ours was direct B2B. And then what we started to branch out to, which became an aha moment and fairly logical after you thought about it, was we work with many of the consulting companies, the engineering and planning companies, the folks that are doing the technical reports. Because what we're fundamentally doing at the end of the day is helping mining companies unlock additional mineral resources and help them add to production. Well, who are the first people in the mining sector that know whether there's extra mineral resources that are not being mined? It's those folks planning all those projects. If they're not in the mining companies, they're in the consulting firms doing all the PEAs, the pre-feas, and the feasibility studies. So it's kind of like an advanced look, and there's a symbiotic relationship there, because what we can bring to those companies is the ability for them to now add another mining method to their planning and demonstrate to their client, the mining company, that they can make their project even more economic. And so we give that to them, and then they become a marketing channel for us. So we've actually started doing this, and for instance, one of our publicly known partnerships is with WSP. So we have a strategic alliance with WSP in this regard. So we've been, that's an area where we've spent a fair amount of time, especially lately, trying to cultivate these relationships. And it's also, the other aspect is the financing partners. What we've learned through, we're raising a Series A financing right now, and a number of the strategic players that have come to the table interested in investing in the round, they're all the project financing firms out there that are financing mining projects. And so they're seeing the opportunity to be able to now finance other types of projects and add to their portfolio. So they could be a lever to kind of help grease the skids with mining companies who are looking for financing to do a surgical mining operation. They also have all of existing portfolio of companies that have these stranded assets in them. So they become a marketing arm for us as well. So we've kind of used them to be able to, and it's the key thing too for us, and I don't know if you guys have felt this, but cold calling doesn't work, right? You need to know people. You need to have a warm introduction. There has to be some sort of initial connection for somebody to take your call, take that meeting. And so these folks, we're talking about WSP, we're talking about some big financing companies where they're very credible. So if our name is attached with them, people will take our call and they'll take the meeting. And that's a very important first step on this journey of trying to get them to adopt your technology.
Yeah, I'd echo a lot of the same. I think your comment earlier on education piece is also part of it. So in addition to, that direct B2B relationship and that people, running down a call list is not necessarily going to get you the right conversations, especially not in an early adoption stage. Everyone loves a case study just like they like being second in. So I think the more that you can come up with digestible and approachable ways to market success in projects and where your technology is at and its virtues is really helpful. And a number of our connections that we've gotten have been being a part of the scientific conversation, especially in water, which is more regulations driven, as well as having those attendance at conferences and speaking to the actual projects completed and capabilities of technology and having people understand and identify it that way.
So us, I'm pretty agreeing with both of you. It's about the same experience we had at ELEMISSION. We are coming from the chemical and engineering, more fundamental science side. So we had to do the B2B in doing those trade shows, showing what we have to propose, doing the publication and stuff like that. At the end, when you attract somebody, it helps you to spread the word of mouth after that. From that, things are accelerating after that.
Well, so Francois, you're also in a little bit of a different position here in that you do have revenue coming in, right? You sell your units, you've got a couple of service lines. How do you keep that engine going?
Well, it's we are several persons that are developing the market. Today I'm overwhelmed with that. I'm looking for somebody to help me because I cannot keep up with the pace. Currently we are 4 at ELEMISSION that are helping me to do that, and it's fun.
Yeah, that's a good problem to have. Yeah. So I'm getting close to the end of my questions. We'll open it up to the group here. But just really quick, you started on this journey. You had the aha moment. You've put time, energy, I'm sure blood, sweat, and tears into these things. What do you wish you had known before you got started? What do you know now that you wish you had known before you got started? Or were you happy to be naive?
No, I'd always like to learn more faster. I mean, the whole idea of fail fast, fail cheap, right? I think for us, I was early on when we did our first financing with Crystal Lake Venture Capital, and one of the partners had told me that building a technology is great, but if you want a valuation lift, if you want to make a big company, you have to really start to figure out your market sooner rather than later, and so the business development side is just as important, actually more important than the widget you're building. And this has been a tough thing for us, that we've kind of gotten pulled back a lot to the technical side because if you look at the makeup of our company, it's like 80% technology development people. So you have all these engineers, data scientists, software engineers building the widget. But what you need is you need a market. You need to be able to get out there, and so the messaging and the product market fit and everything related to kind of building that customer base, especially that early adopter customer base, like it's just so critical, because at the end of the day, like I've been through countless venture capital meetings, and I could tell you how much time we spend on talking about the technology versus we talk about the market. Right? So like, they want to see validation through customers. If we're talking to customers, if we're in the field with customers, if we have customer contracts, that is very easy validation for an investor to say, yeah, they've got something here. Because at the end of the day, I mean, what we're building, I think is incredible. I think it's differentiating. I think it's transformational. But if you put enough people on it, you can make it work. It's the business development side that is crucial to a company's lifeblood to be able to continually raise capital and do what it wants to do to ultimately become that. Everybody in the startup world wants to become a unicorn, right? They want to be the billion-dollar company. So in order to do that, you really need to spend a whole lot more time on the business development side as opposed to the technical side. So I would say, like, I always look back and be like, okay, I really wish we got some good advice early on, but you get pulled in a lot of different directions. So ideally, if we could have spent more time on that earlier on and bring on more resources earlier, I think maybe we'll be in a different position, maybe we won't. But that's where I would make some changes.
Well, that's a little bit counter to kind of the other conversations that we're having today, that it's all about the innovation and the technology. Maybe we should have a whole separate conference on just business development. Could be interesting. Zach?
Yeah, I'd say yes to all of that. Adding to it, I guess, in terms of, I think, understanding your comparables as a business, there's a lot of startup and new technology advice out there that is perhaps not the right fit for what you are doing and what sort of pathway you have. I remember sitting in a webinar at one point with Blue Tech Research that was talking about a high-velocity water treatment startup is 8 years to get to market, and it was like in year 2 of us working, it was like, oh, okay, good to know. So I think in that respect, it's just understanding too how that might influence things like what is your approach to financing, how fast are you growing the business, and what is your expectations on how long a project or a certain client is going to take to get to maturity. So some of those elements, and then a COVID pandemic in the middle of it, are all that it takes to sort of stretch some timelines, and having to be adaptable to that. I think that would be the other second part, is just eyes open for other opportunities. We've had this technology we've been developing, and through the process of a couple of things, just observing how it's working, we've identified some other use cases for it that may catch up to and even pass the rate of adoption for that first use case. And those are interesting things to have been picking up. If we were just too tunnel focused on the one use case, we might have missed some of those opportunities to diversify a little bit. So, yeah.
Great.
For us, I think it's investing in business intelligence a few years before we did. But roughly, you have a compromise. Everything is a synergy. Okay, you have to bring your technology ready to the market before you start commercialization earlier. But you have to be ready when the customer is ready, because delivering failure is not good for your reputation. And the reputation is hard to build and fast to be destroyed when you deliver failure. So roughly, I think business intelligence is something that I would have invested a bit earlier.
Well, right on. Appreciate that. Maybe we'll turn it over to the crowd. I see Peggy's hand went up almost immediately.
No, because I think from the business development side, makes my heart sing. So, because that's often still overlooked, that I can't iterate enough when you are building your product, which many of us do come from the mining side, is to understand the value chain and what the triggers are. So, what are the triggers that's going to be we're going to buy? Coming from a lab background, I can understand the one piece of equipment, but
Thanks for echoing that. Any other questions? I see a gentleman here. Yep. Appreciate that. Anyone else? Yes, over here.
More of a comment. You had mentioned that we need to make sure your champion sticks around. It's definitely a problem with road mining companies. And typically your entryway is going to be someone at the superintendent level or more, right? They're typically going to be your champion. They're the SME in the area. They're going to be championing for you. And in my experience, those succession plans kind of fall off after you get to the manager level, and you lose the succession planning for the SMEs. I'm hoping that changes because I think mining companies are struggling in that space. But in the meantime, equipping your SME, your entry point, your champion with graphics and stories helps them generate excitement. If they get asked, what are you excited about? And they have a graphic that's ready to go, then you've made someone else excited about your product too. That goes a long way.
Yeah, and what we've noticed is too, like as we've evolved and we've gotten in the field, you know, we take videos and we've got data points and we make you know, process videos on how you do surgical mining. All those things now become collateral that we can pass on to the champion, so they can use that. And essentially, like, we're just trying to support the champion, right? Because that's at that point, that's our role in sort of entering the business. But for us, in you know, as a startup, like in the mining industry, it is a multi-tiered, multifaceted sort of selling proposition. It's a complex sale that requires decision-making from many different folks. In certain cases, it goes all the way up to the CEO, back down to the field level. And we have to be able to talk to all those people and have the right messaging for each one of those to hit their hot buttons, to be able to help them understand what I talked about before, the value, you know, how is it going to potentially be disruptive, what are the risks, you know, all those things, sort of the business case. But they all speak a different language and they all have different incentives. So you have to be able to speak to all of them, and you need all of them, because I haven't encountered one time yet where I talk to one person and they say, yeah, let's do this. It's always, you know, let me bring in these people. Like, you know, some of the large mining companies, like, you know, we have our database. There's like 20 people in our database with a company, and they're on, you know, you get on these meetings, and it's myself and maybe two of the Novamera people, and there's 15 people from the large cap producer. You know, it's like, you know, everybody has to be involved. So you have to be able to manage that, and you know, that's part of the difficulty and the challenge of complex sales, right? They're long, and a lot of people have to be involved. So you've got to be able to speak to all of them.
Any other thoughts, comments? You pick up on what?
Yeah, the graphics is a good point. I also just might as well have an auto message to my team of like, take more pictures, because often, yeah, the engineers out in the field are too busy, you know, checking on how things are working instead of being like, oh yeah, nice product shot. So I think that, you know, those communications, the presentations.
Do you guys see what RockMass did?
Yeah.
Yeah, they came up on stage and they had the photographer.
Great show and tell. I mean, it really is important. And yeah, I think just echoing that message too, that I think also being adaptable to once you hear a message from somewhere up the chain on like, this is the priority, actually not, you know, do this part of the treatment process differently, is just being adaptable to reiterating that into the message in terms of how you're communicating. Yeah.
Maybe one last question before we call it a show? No? Okay, well, this was the last thing standing between you and another coffee break. I encourage everyone to stretch, wiggle around a little bit, maybe get those muscles moving a little bit, move the blood around, and we'll be back at 3:15? 3:20. You got a little bit extra time. Thank you, gentlemen.
Thank you, Kyle.